from Idaho. I strive to provide interesting videos about motorcycles, fabrication, welding, electronics, machining, and general creativity. I hope you enjoy. Hello from Idaho. Today we're going to upgrade my hydraulic press. I bought this off of Facebook Marketplace or Craigslist, I can't recall, a dozen years ago. It's a no-name press. It wasn't put together when I got it. It was missing some hardware. But I put it all together and it works pretty darn good. I've straightened the forks on motorcycles, pressed bearings in, bearings out, put a gentle curve in a 1/2-inch steel plate, done various pressing things. Ideally, I want to have a finger press added to this, but for now I need to make a couple of changes to get ready for that. Today we're going to replace this bottle jack with an air over hydraulic jack. When you jack this up, it moves maybe 50 thousandths of an inch per jack, which is great for precision pressing. You can get very small movements when you need them. But if your piece that you want to press is down here, moving the ram down 2 inches takes a really long time. And so with an air over hydraulic jack, you still keep the jacking ability, but you can move the jack down using air. And they put a piston on the back of the jack, and the piston does the pumping. And it's a direct replacement. This jack is not bolted down at all, and I happen to like it that way. It's captured in this big ring up here, and I've moved it down the driveway all over my shop, over cables and cords and stuff like that, and I've never had any problem with it coming loose or anything, so I don't think it needs to be tied down. The air over hydraulic jack has a little bit bigger base and sticks out farther in the back, but essentially you just pull this down, take this jack out, put the other one in, and let it go back up. So that's pretty easy to do, and I don't need to make a video about that. The jack comes with a hand valve to actuate it. It's just a hand actuated valve. But when you're pressing something, sometimes you need 3 hands, and if you've only got 2 and one of them has to control the air, why, that's really inconvenient. So I would much rather have a foot operated valve that so that I can have my hands free, and I just put my foot on the valve and press down, and everything works much better that way. So most of this video is how to make a nice, inexpensive foot operated valve and put it in a location that's easy to use. Okay, here's my jack. It's an air over hydraulic. I got it a couple years ago off of Facebook Marketplace, knowing that I would eventually upgrade my hydraulic press. It's 20 ton, fairly typical. It still allows you to manually jack it up, and it has a relief valve here. It comes with a air hose and some handles and this air valve, which is what I'm going to make into a foot valve. Okay, if you watched any of my previous videos, you know that I pretty much always create a set of plans. The only real thing that needs to be fabricated for this project is the foot switch. I'm going to have the foot switch on the right hand leg. Here's the caster at the end of the leg. Here's a boot. The foot switch is right here, and it's captured between these 2 elements just by the fittings that go in them. I've used this technique before. It actually works pretty good. The only thing is that this measurement here on the angle iron On the angle iron, the distance between there and the center of that hole is a little bit critical. It's the only critical dimension on the whole project. This angle iron will make sure it can't twist like this, and it'll be held up tight there, and then this one will box it in, and so the foot switch won't move around at all when you put your foot on it. And it lets me use the existing valve, which saves me 20 bucks or so. And the bracket cost me nearly nothing. I've got all these parts out of scrap. You can see the top of the air switch. This red piece is the same as this red piece down here. And the two little gussets go here. All this welds to the bottom of the foot. You can see that here pretty clearly. Here's the leg with the caster, and everything welds to the bottom. That gets the foot switch pretty close to the ground, so it's not uncomfortable to use. And then in order to keep the hose out of the way of the user, this fitting comes out, goes through a 90, and then I just put a regular air chuck fitting on there, and so the air hose will plug in here, and the human stands in this area, because this is the right leg and the upright is right about here. And so the human stands in between the two legs, and that's about as simple as I could make it. So here's page 2. It's a detailed drawing. Side view, top view, front view. So we get all these pieces dimensioned. This is basically 4-inch flat bar stock, 1/8 inch stick. We've got some 1/8 inch angle iron right here, and a piece of 1/8 inch flat bar here. And then the gussets are made out of 1/8 inch flat bar here. The tread place for the foot is just this round pin, and that's 1/2 inch round bar. And from the front you can see the different elevations and where the foot goes and where the gussets go. Don't mind the extra hole. I marked it on the wrong side of the line the first time. Okay, my first hole was 17/32, and it was a little bit snug. Those NBT threads are tapered, and so right up near the end it was pretty snug. So I'm going to go up to 9/16 here, and that's only a 32nd bigger. There's a good chance this is going to try to catch and rotate So I have it clamped down in a way that holds it down and keeps it from rotating. So stand by for the excitement. And if you have it clamped right, there is no excitement. Okay, we have all of the major pieces made. Here's the major part of the bracket and the angle iron with a hole in it for the foot valve. So here's the foot valve, there's the angle iron. It's really hard to find 9/16 inch washers unless you go to a specialty place. Most hardware stores go up to half. But they do go up to 14 millimeter, which is just about 9/16. So we'll use, this will not be the spacing finally, but because it's not seating completely in the valve, but it will hold it together for my demonstration. So that goes there. And then we have our angle iron, or I'm sorry, we have our angle fitting that turns the air out the side, and this will get tacked into this place and then welded. And we have our peg for the foot, and so the foot will sit, or the boot will sit like this and press down on the valve, and it will let air into the jack. We've got our 2 gussets cut and our 4 pieces of tubing that will control the routing for the air hose. So it's about time to tack this thing together. Okay, we're all set up to tack the angle iron. Normally I would just MIG tack it and MIG weld it. There's nothing special about this, but I got a new welder and I want to spend more time on TIG, and so I'm gonna do this project, or at least parts of it, with TIG. So should just take a couple of little tacks to hold this thing on. Okay, here's a little bit about my setup. I like to put things in a vise for welding. This is my steady rest. It's just an old laboratory stand, the kind we used to use in grade or junior high chemistry, and it adjusts up pretty far, and this rod is a couple of feet long, and it gives me it gets me back some of the steadiness I had when I was young. I have a tungsten only grinder, little 4-inch, but I bought it off of Facebook Marketplace. I dedicate one wheel to aluminum, the other wheel to steel, and that way I don't get any contamination. I use leather fence making gloves. I like those better than the heavy ones. I have to have, here's my little helmet stand that we made in the last video. I have to have hot coffee. Here's my little torch holder that I made on the milling machine. It holds MIG and TIG and cutting torch, and you can have the cutting torch running when it's on here. And so that's been very handy for me. And here's one of the abominations that I really hate, is the foot pedal comes with 25 feet of cable. Well, that's great, but my TIG torch's cable length is only about 8 feet or so, and so I have this big snare, and I'm working on a wireless design. The CAD drawings are all done, the schematics are all done. I just need to buy some parts. And here's one of my recent modifications. The Everlast comes with a really nice Nova foot pedal, but it doesn't have a perimeter on it. So I put this little 1" by 1/8 inch parameter on it, so that I always have positive registration on it with my foot. I can always feel this perimeter and I know exactly where I am. For those times when you use the thigh master approach for TIG pedals, it's a little bit less comfortable, but it also doesn't fall off of your thighs or your knees with that little perimeter on it. So I like it. Okay, now back to your regularly scheduled flashy thing. Okay, now I've got the foot valve, the air valve, in its location, and I'm using it to locate this piece perfectly. Not that it needs to be that perfect, but I just like it to be boxed in pretty well. So let's get this tacked in, then we'll get the air valve out of the way. Okay, now we can run it in there. A little more permanently. Okay, it's time to put the new jack in the press so that I can measure for hose length and hose path down to the foot switch. I'm standing on the back of the jack. The front will have the switch, the air switch, the release valve, and the jack handle. So now I do need to jack this up. And unfortunately I have to do it the slow way because I don't have my air fittings all hooked up. This goes up inside that little recess, 7/8 of an inch. And the return springs get to go right up in that channel iron as well. Okay. Now we are actually pushing down the ram, and so I'm going to run the air hose down this rail, and then underneath the rail and into the hose. So it looks like I probably want my first air hose control thing there. And then down here, I want one near the bottom. And then I'll evenly space the other two. But that will allow me to control the air hose. It won't get hooked on the work pieces. It won't get hooked on other stuff in the shop. So I think we have a plan. Okay, I've got the stripped down press frame on my welding table. I've got the locations for the air hose guides marked out, 4 evenly spaced locations along here. I'll just take a piece of flat aluminum and clamp this up here and then weld it down, and that way the table that slides up and down here will not have any interference. I've also marked the bottom of this leg because this is where the air valve goes. Okay, it's time to do a little final plumbing on the foot valve. Here's my valve. That used to be a hand valve. Now it's going to be a foot valve. I'll put it in first with a quick disconnect. The reason I'm using a quick disconnect is so that the jack can have a regular quick disconnect on it. And so it could plug into any air system. And so I could actually take the jack off of the press and use it to jack up a truck or a foundation or whatever, whatever heavy thing you have. And then we need a little nipple to get us far enough away from here so that we have room for an air fitting. And then a 90. Okay, that's all started well. So we're going to tighten this one first. It's the one that it's the one that controls how sloppy the valve is. And we should be able to get all the slop out of it if my measurements are correct. Okay, right about now, we're tight enough that it would hold air, but we're going to continue to tighten it and see how much of this slop we can get out of it. Okay, it's beginning to be pretty tight. In fact, right there, it just locked up everything. So I think we've achieved what we were headed for. Now the valve can't move, and we finish turning in this one. Then we can put in our quick connect air fitting so that it'll hook up to shop air. And this little part is done. It's been all welded up and painted. Could be bolted back on after we're done here. Okay, it's getting pretty tight. See if we can make another 3/4 of a turn and head it out the right direction so that the air hose is out of the way of the user when the press is in use. We'll just run it under this leg and away from the press. Okay, that's about where we want it. Yay. Now we can put on our quick disconnect. Now we're ready to put it on. And this part will be done. I've got one coat of paint on my air hose guides, so we'll put another one on tonight before I go to sleep. Okay, we're getting tight, and we are done. So let's see if shop air will hook up to it. Yay. Okay, we have a finished product. So the plumbing at the jack is a T and a ball valve, and then the hose. The ball valve allows me to open this, put a couple of drops of air tool oil in there, close it, and then that will make the jack last nearly forever. I use this technique on other tools, and I've never had a problem. So the air hose runs down the side through the little guides that we welded on, and then it comes out from the guide, goes underneath and plugs into that quick disconnect. And then of course on the other side is the valve that is now foot operated. Okay, here's the hydraulic press from the front. The new air over hydraulic replaces the old jack. I've got my little 5-shooter release knob that I made before. And of course I can use a jack handle if I want to. This press has a little gap right here, which is perfect to put my jack handles. And I've got my press plates here on the sides. I'm going to have to double check that stroke again. That was for my old jack. I can't ever remember it, so I just write it down. And the part that makes this most useful to me is this foot valve. I just put my foot on it, press down, and the jack operates. That way I have two hands free for press and pin alignment. And the best part is the shop's all clean. My hydraulic welding table is empty. And it's time to run Roomba and pick up all my stuff. Goodbye from Idaho. As usual, if you like or dislike my video, please select the appropriate button and let me know why. I really appreciate comments and I will answer every one. If you're new to my videos, please select the subscribe and the notification bell to get more videos like this.